discuss the plane concept is there. Okay. Please stay on the line. Students, now see the plane. What is the plane? Already you have discussed the plane concept is there, and first of all, we must the general form of a plane. What is the plane? The plane consists at least 3 points. Suppose here capital A, capital B, capital C, or any 3 points is there. Okay, there are 3 points, triangle ABC or angle ABC, whatever it is. Now that is the form of a plane is there. Okay, yeah, a plane, the plane consists at least 3 points, either XYZ or PQ or whatever it is. Okay, now we are taking any 3 points to arrange the, there are 3 sides of the part. Suppose AB is one of the side and BC is one of the side and CA is also one of the side. Okay, that is the definition of a plane and that is the structure of a plane. What is the general form of a plane? See this one. That is the, see the 41 page, the concept of a plane is there. Okay. Already you have discussed the some other important problems yesterday class. Now we will see the plane concept is there. Now the general form of a plane equation is ax plus by plus cz plus d equal to 0. That is the general form of a plane equation. Okay. Now here ABC, in this plane, the general form of a plane equation, here ABC be the drs of the plane. Okay. Now those drs, according to the drs, we will find the dc's of a part. Okay. What is the dc's? That is the direction cosines of a plane is there. Now here ABC be the drs of a plane, and here according to the dc's of a plane, a by root of sigma a square and b by root of sigma a square and c by root of sigma a square. That is the form of a plane equation. See this one. Okay. Now here a surface is also called a plane. That is the main concept is simply you have to see this one. Giving according to the through the dimensions, just you have to just one of the diagram of this part, a surface, you are taking the one of the surface. Okay, simply surface is also called a plane. Surface or a plane if all the points of a straight line joining any 2 points on the surface lie on it. Okay, a straight line joining any 2 points on the surface lie on it. Through the concept of a plane, it is issued to be known and it is desirable to characteristic of a plane as follows. Suppose here A and B are any 2 intersecting, A and B are any 2 points, and through the origin we are connecting in between the A and B, that is OA and OB be 2 intersecting lines. Okay. Now here the set of all points capital P such that through the origin OP bar equal to lambda OA bar plus mu OB bar. Okay, that is the constitutes of a plane is there. Okay, now just what is the equation of a plane? Just you have to see this one. What is general equation of a plane is every equation of the first degree in XYZ represents a plane is there. Every equation Okay, now enter that equation, the general equation of a plane in terms of xyz is there. Okay, that is the first degree equation, because here each and every degree is 1 through the coordinates of the point. Here ax plus by plus cz plus d equal to 0. Simply here abc are real numbers, but not all equal to 0. Hence the condition is sum of the squares of the real numbers a square plus b square plus c square, enter that concept not equal to 0. That is the coefficient of xyz. So coefficients of xyz are ABC. Now those ABC are called real numbers, but now sum of the squares are the a square plus b square plus c square not equal to 0. That is the important condition of a plane is there. So here the first equation, this is the general form of a plane equation, that is ax plus by plus cz plus d equal to 0. Okay, now here we have to show that every point on the line joining any 2 points on the locus, okay, locus first equation locus, it is also lies on the locus first equation. Okay, suppose here x1 y1 z1 be the one of the point, then the locus of xyz is there. So here we are taking the any 2 points P of x1 y1 z1 and Q of x2 y2 z2. There are any 2 points on the plane equation. So then we will form the plane equation through their points ax1 plus. Oh, so suppose P and Q, there are 2 points. These 2 points are satisfying the general form of a plane equation. So substituting in first equation, there are these points. We are getting the ax1 plus by1 plus cz1 plus d equal to 0, and again ax2 plus by2 plus cz2 plus d equal to 0. Here capital R be any midpoint on the line segment joining the points P and Q. Suppose P and Q are there are any 2 points. R be the one of the point. That point it is line segment joining the points. So capital R divides in the PQ. So here R be any point. That point it divides the PQ in the ratio lambda is to 1. Already we know that as an internally or any section formula is there. Here capital R be the point. What is the section formula? Through their points P and Q. Okay, in the ratio of lambda is to 1. So in the lambda is to 1, it is comparing it with lambda 1 is to lambda 2. Okay. Here capital R equal to section formula lambda x2 plus 1 x1 by lambda plus 1. So mx2 plus nx1 by m1 plus m plus n, or m1 by 1 plus m1 by 2 plus m2 y1 by m plus n, or mz2 plus nz1 by m plus n. So here in the replacing of m and n by lambda and 1 is there. We are getting the section formula lambda x2 plus x1 by lambda plus 1, lambda y2 plus y1 by lambda plus 1, lambda z2 plus z1 by lambda plus 1. Now this point treated as in the coordinates of the point x coordinate, y coordinate, z coordinate. This point satisfying in the third equation. Okay, a of x means lambda x2 plus x1, y means lambda y2 plus y1, because here the lambda plus 1 is common in the denominator of the coordinates of the point. Okay, now that denominator is cross multiplying, we are getting the 0 is there. So that's why replacing a of lambda x2 plus x1 and plus b of lambda y2 plus y1 plus c of lambda z2 plus z1 plus d of, here d is constant. Okay, now that constant is also multiplying with because here the lambda is lambda plus 1 is there in the denominator part. So that denominator after the LCM, we are getting the value of constant is d of lambda plus 1 equal to 0. So finally we are getting a of lambda x2 plus lambda 1 by lambda plus 1, b of lambda y2 plus y1 by lambda plus 1, c of lambda z2 plus z1 by lambda plus 1 of plus d equal to 0. So here that given this point x coordinate, y coordinate, z coordinate, it lies on the locus first equation, that is the general equation of the part, for every value of lambda. But here lambda not equal to minus 1, because if it is lambda equal to minus 1, we are nothing to prove and to express the general form of a plane equation. So finally here ax plus the surface given by the equation, first equation represents a plane is there. So finally what is the general equation of a plane, students? Ax plus by plus cz plus d equal to 0. That is the general equation of a plane is there. Okay. Here the vector equation of the plane passing through the point already this type of problems are also practiced in the vector algebra. Okay. Now, that algebra is also consisting vector coordinates of the part through the line and through the plane. That is also in an intermediate level is there. But here it is also expressed in this, especially in this part. Here, given that point passing through the point Q point, plane passing through the point Q is given by n dot PQ bar equal to 0. That is the represents of a plane through the vector notation. Okay. N dot of PQ bar equal to 0. PQ bar can also be written as in the vector notion OP bar minus OQ bar minus OP bar. Okay. Already we know that OP bar is small r, that is the position vector. So that value is substituting given this expression n dot of r minus OQ bar equal to 0. Okay. Now here the students listen carefully. This is also an important corollary part. Please stay on the line. Please stay on the line. Okay. Now see this corollary. Now one point is given. Okay, what is the equation of a plane passing through any point? Here the point is x1, y1, z1. Then it is of the form a of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. It is very simple. One point is given, and to form the plane equation through the form. Okay, that is the simple expression is there. So here the point is given x1, y1, z1. And what is the form of the plane equation? Through this one, a of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. Okay. Now that is also very simple proof is there. Proof is not necessary, but we must know that what is the proof of giving this expression. First of all, write the plane equation ax plus by plus cz plus d equal to 0. And this equation, so first equation satisfying the given the point, suppose let x1, y1, z1 be the point in the plane. So that point is also substituting in the first equation. We are getting the ax1 plus by1 plus cz1 plus d equal to 0. So after this substitution, here d equal to minus of ax1 plus by1 plus cz1. Say that is the second equation. So from the first equation and the second equation, we have the d value substituting in the first equation. We are getting the expression is ax plus by plus cz minus of ax1 plus by1 plus cz1. Okay, equal to 0. Now here ABC is the common given this expression. So finally we are getting a of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. This is also this is the suppose x coordinate, y coordinate, z coordinate is there. Already we know that suppose one point is given. Suppose x1, y1, z1 equal to 0. Okay. So finally ax plus by plus cz equal to 0. So given this point is origin, when the point given this plane point passing through the origin, so d equal to 0, because replacing the coordinates of x coordinate, y coordinate, z coordinate, that is when it is 0, x equal to 0, y equal to 0, z equal to 0. So we are getting the values d equal to 0. After the substitution of the general equation, we are required the condition is ax plus by plus cz equal to 0. Suppose any plane passing through the origin, then the plane equation is ax plus by plus cz equal to 0. That is one of the important note. So the same expression x1, y1, z1, those values are substituting origin 0, 0, 0. We are getting ax plus by plus cz equal to 0. Okay, one point is given. Suppose here the converse. What is the converse? The equation of every plane is of the first degree in x, y, z. So what is the normal form of the equation of a plane? Very important the concept. What is the normal form? Lx plus my plus nz plus p, nz equal to p. So important note, students, according to this figure, because you must know each and every one through the definition and through the graph. That also one of the graphical representation. Now easily to understood, enter the concept of three-dimensional geometry. three dimensions means it is very simple. X, Y, Z axis. That is the three dimensions. Dimension, it is also in the similar name of axis and ray or line, whatever it is. And through the over the three dimensions, we will explain the we must explain the concept of a line, plane, sphere, circle, cone, cylinder, paraboloid, ellipsoid, whatever it is. Okay. Now, just you have to see this one. What is the how to construct the normal form? Now, according to the dimensions here, these three axes meet the point is called an origin. Just you have to draw the one of the point in between the dimensions. Suppose P be any one of the point. So OP is one of the direction. Well, that is the position vector. Okay. Now a triangle ABC, triangle ABC means x-axis the point is capital A, y-axis be the point capital B, z-axis point is capital C. So ABC determines a plane is there. We call it this is the ABC be a plane. Okay. Now O be the outside of it. So OK is perpendicular to the plane. Just you have to see this figure. See this diagram. Okay, OK. Here this is the OK. Okay, OK is the perpendicular to the plane. So the small p be the length of the perpendicular, small p be the length of the perpendicular from the origin to the plane. So OK distance is small p. Small p be any positive number. There is no doubt. Okay. Here let L, M, N be the DCs of OK. Okay. L, M, N be the direction. DCs means direction cosines of the OK. Okay, point is x, y, z, be any point in the plane and join OP and OK. OP and OK be the both are joined is there. So OK is the projection of OP on OK itself. Okay. Now that's why here the direction cosines is LMN and origin is capital O of 0, 0, 0 and point is x, y, z. So according to the already one point is given. Okay, here according to the DC is how to construct the plane A of x minus x1 plus B of y minus y1 plus C of z minus z1. Okay, here ABC in the replacing of ABC by just you have to see here L, M, N is there. So here L, M, N be the LMN are the direction cosines. So replacing of the x1, y1, z1 is origin. So L of x minus 0 plus M of y minus 0 plus N of z minus 0. Finally, we are getting the value is Lx plus My plus Nz is there. So since the projection OP on OK, so OK distance is small p. Finally, here Lx plus My plus Nz equal to P is there. So the equation of the plane ABC is Lx plus My plus Nz equal to, so according to that angle, because this is the adjacent side by hypotenuse, so that is cos theta. So that is then the angle is P cos theta. Okay. Now here the through this angle of the plane equation, because show this figure. Okay, ABC be the plane. So here the form of the angle is that is the cos theta of this part. Okay, OP because OK distance is small p, and according to that is the adjacent side of the hypotenuse ratio. Okay, so that's why here Lx plus My plus Nz equal to P cos theta is there. So that is the equation of every plane. It is of first degree in XYZ. Yes, okay. So students, listen carefully. What is that? The general equation of a plane is Ax plus By plus Nz equal Nz, Ax plus By plus Cz plus D equal to 0. And according to the general form, to construct the normal form of the plane equation is Lx plus My plus Nz equal to P. It is called the equation of the plane in the normal form. Here the important condition is when the coefficient of x, y, z, L square, L, M, N, then the sum of the squares L square plus M square plus N square equal to 1 is there. Okay. Now in this figure, OKB is a right angle triangle. With right angle at K, OK equal to OP cos theta. So that's why you are taking the Lx plus My plus Nz equal to P cos theta. Okay. Now OP is the sum, OK means that value is an equivalent to OP. So that value is small p cos theta. So theta is the angle between, what is the theta? It is the angle between the above figure, shown in the figure, OK and OP. That is the acute angle. Okay. So what is the vector notation of the part? The first equation, it can be written as r dot n equal to, here the normal form of the vector equation, r dot n equal to small p. Here r is the position vector of any point and n is a unit vector along here. What is the r? What is the n? R is the position vector and n is a unit vector along OK. Okay. What is the transformation to the normal form? This is also one of the important, and you have to practice. It is a continuous part of from the beginning of this part. Now we have to learn the plane concept. Okay. Now what is the transformation? Please stay on the line. Please stay on the line. Okay. See this one. What is the transformation of the part? Okay. See this one. What is the transformation to the normal form? It is very simple. Here ax plus generally to write as the general equation of a plane, and again to write the normal form of the plane. Those two equations represents the same plane. So comparing the coefficients of x, y, z, here a by l equal to b by m equal to c by n equal to plus or minus, here the coefficient of x, y, z is a square plus b square plus c square, sum of the squares, by square root of L square plus M square plus N square. Already we know that here the sum of the DCs, here LMN, sum of the squares of the DCs, that value is also 1. So we are getting the final expression is plus or minus square root of A square plus B square plus C square. So here what is the value of L? A by L equal to plus or minus. Each and every one, it is an equivalent to this one. So we are getting the values of LMN. So L value is plus or minus A by root of sigma A square, means A square plus B square plus C square, and M equal to plus or minus B by root of sigma A square, and N equal to plus or minus C by root of sigma A square. Now again this value P, what is the value of P? Now P equal to minus or plus, because minus D by P equal to this one, minus D by P equal to this one. So we are getting the value is P equal to minus of minus or plus D by root of A square plus B square plus C square. Now these values substituting in the general equation of a plane, finally we are getting the A by root of sigma A square into X, B by root of sigma A square into Y, C by root of sigma A square into Z equal to, plus D is also converting into this side, because replacing of the value P is minus D by root of A square plus minus or plus minus D by root of sigma A square, where entire the concept is also multiplying with minus, where finally minus A by a minus or plus is there. So here D is negative, and when D is positive, we are taking the minus or plus value is there. First of all, so we are taking the value is minus, and the second one plus is there. Now here D is negative, we are getting the value is minus D by root of a sigma A square. When the D is positive, D by root of sigma A square is there, because root sigma, here sigma A square means it stands for, what is the sigma A square? It means A square plus B square plus C square. Now this is one of the important note is there, students. What are the DRs of the normal of the plane? A, B, C, be the normals to the plane. That is called the DRs of the normal. See this one. In this expression, A, B, C be the DRs. That is the general equation. That is the coefficients of x, y, z. What is the perpendicular distance from the origin to the plane? Already we know that plane equation, Ax plus By plus Cz plus D equal to 0. Okay. Here the perpendicular distance from the origin is plus or minus D by, this is the formula. Okay, plus or minus D by root of A square plus B square plus C square. That is the from the origin to the plane, perpendicular distance from the origin to the plane is plus or minus D by root of sigma A square plus B square plus C square. That is the from the transformation we are requiring this value. Okay. Now let us, you have to see the problems. Okay, find the DCs of the normal to the plane x plus 2y plus 2z minus 4 equal to 0. Here the normals dr. First of all, to write the general given equation to the plane is x plus 2y plus 2z minus 4 equal to 0. Say that is the first equation. Here the coefficients of x, y, z are 1, 2, 2. So that is the drs of the normal. Okay, and according to the 1 to 2 is there. So for here the expression is DCs means L equal to a by root of sigma a square. A means 1 by root of sigma a square means 1 square plus 2 square plus 2 square. So that value is root 9. So that value is root 9 means 3 is there. So L value is 1 by 3, B value is 2 by 3, C value is 2 by 3. Okay, and here the LMN means that is the DCs of the plane. Okay, that is one of the important notes, students. Through the general equation to the plane ax plus by plus cz plus d equal to 0. Number of times I must repeat it here. Don't deviate here, especially because one of the important concept, especially from the beginning beginning of the three-dimensional geometry, each and every concept you must learn and you must practice. Okay, through this session. Okay. Here L value is 1 by 3 and M value is 2 by 3 and N value is 2 by 3. Okay. Now, these problems are also given in the some other, either some other university entrance examinations is also given. Okay. Either JEE, whatever is in intermediate level. Okay. In intermediate level, or suppose you are going to the JLS exam, whatever it is. That is the simple expression. These problems are also given in the bit oriented. Okay, that is a multiple choice. Now the perpendicular distance from the origin to the plane is 3x plus 4y minus 12z plus 65 equal to 0. What is the from the origin to the plane? D by root of sigma a square. Here a means 3, b means 4, c means minus 12. So d value is 65. So according to the formula, from the origin to the plane of the perpendicular distance, d by root of sigma mod d by modulus d by root of sigma a square means 65 by root of 3 square plus 4 square plus minus 12 whole square. So after the simplification, we are getting the result is root 169 minus 9 means that is the 13. Okay, there are that is 65 by 13. What is the value of 65 divided by 13? That is that value is simple value is 5. Okay. Now here one of the problem is there. Reduce the equation. Given the plane equation is here, that equation can be transferred into the normal form. So given the plane equation is x plus 2y minus 3z minus 6 equal to 0. Now comparing it with the general equation. Here a value is 1, b value 2, c value minus 3, d value is minus 6. So suppose d is less than 0. So after getting this one, less than 0 means that is the normal form is we are taking Lx plus My plus Nz equal to P is there. Well, when the d is less than 0, we are taking the P value is minus d by root of sigma a square. So L equal to a by root of sigma a square means L value, that is 1 by root of 1 square plus 2 square plus minus 3 whole square. So after getting the value 1 by root 14. M equal to, so M equals to B value is 2 by root 14 and N value is that is C by root of sigma a square minus 3 by root of 14. P value is minus 6 by, D value is minus 6. So minus 6 by root 14 minus of minus 6 because P equal to minus D by. So already D value is minus 6. Minus of minus means positive. We are getting the value 6 by root 14. Okay. Finally, the normal form of the given equation to the plane is 1 by root 14 of x plus 2 by root 14 of y minus 3 by root 14 of z equal to 6 by root 14. On the these values are LMN values substituting in the normal form. So that is Lx plus My plus Nz equal to P is there. Okay, that is the normal form when d is less than 0. Okay, now these problems are also practiced here and the same now it follows the above problems. Now let us we especially your convenience just you have to practice. These problems are also mentioned here. Find the DCs of the normal to the plane 2x minus 3y plus 6z equal to 7 is there. What is the DCs? Here A, B, C is there. A value 2, B value minus 3, C value 6 and L equal to A by root of sigma A square, 2 by root of 2 square plus minus 3 whole square plus 6 square. 4 plus 9, 13, 13 plus 36. 6 square means 36. That is the 39, 49. So root 49 means 7. So 2 by 7 minus 3 by 7 and n value is 6 by 7. Okay. That is the simple expression. That is the simple normal to the plane. If I reduce this equation into a normal form. So first of all, so we are getting the here d value is minus 21. That is also less than 0. So that's why we are taking the Lx plus My plus Nz equal to P. P value is minus d by root of sigma A square. After the simplification, L equal to 2 by root of A square, B square, C square. 2 square means 4 plus 36. That is 40. 40 plus 9 root 49. So L value 2 by 9. M value minus 6 by 9. N value is 3 by 9. Okay. And P equal to minus of minus, that is 21 by 7. Okay. 2 by 7 minus 6 by 7, 3 by 7 and P value is 21 by 7. Okay. That's enough. Okay. And students, listen carefully. We are taking according to the plane, we are taking the normals A1, B1, C1 and A2, B2, C2. There are different normals we are taking in the plane, the normal to the plane. So A1, B1, C1 is the first normal. Normals are first plane equation A1x plus B1y plus C1z plus D1 equal to 0. This is the first plane. And second plane is A2x plus B2y plus C2z plus D2 equal to 0. These two planes are intersecting because common point. Now this point XYZ is the coordinates of the point in the both planes. That is the same point on the both planes. That's why we are taking the A1, B1, C1 is the represents to the first plane of the normals. That is the DRs. Second plane to second plane of the DRs A2, B2, C2. According to their normals or DRs, how to find the angle between the two planes in between. Okay, that is one of the important concept because that is a simple concept. The angle between any two planes is cos theta equal to plus or minus A1 A2 plus B1 B2 plus C1 C2 by root of sigma A1 square into root of sigma A2 square. Now it stands for root sigma A1 square means A1 square plus B1 square plus C1 square. Root sigma A2 square means root of A2 square plus B2 square plus C2 square. Now that is the simple expression of the angle between any two planes. Suppose these two planes are perpendicular. First plane represented as the pi 1, pi 2 or whatever it is, capital P1 or capital P2, whatever it is. Okay, these two planes are perpendicular. Perpendicular means then the angle is theta equal to 90 degrees. Now the replacing of given this expression cos 90, already we know that cos 90 is 0. When the cross multiplying, we are getting the condition is A1 A2 plus B1 B2 plus C1 C2 equal to 0. That is the condition of the when the perpendicular to the planes. Suppose those planes are parallel, either parallel or coincide. So when the theta equal to 180 degrees or 0 degrees, 180 degrees means that is the pi. Okay. Or now 0 degrees, either pi degrees or 0 degrees. Okay, pi radians or 0 degrees is there. Now, parallelism condition is A1 by A2 equal to B1 by B2 equal to C1 by C2. When the both given the planes are parallel, then the ratios are also proportional. So that proportional condition is A1 by A2 equal to B1 by B2 equal to C1 by C2. At the same time, it can also be written as A1 is to A2 equal to B1 is to B2 equal to C1 is to C2. Okay, there are two important conditions. Suppose given the examination, the final examination, find the angle between the planes. There are two planes is given. Okay, this is A1, B1, C1. First of all, to write the given planes are 2x minus y plus 2z minus 3 equal to 0. To write as the second plane 3x plus 6y plus 2z minus 4 equal to 0. Okay, here A1, B1, C1 means 2 minus 1, 2. A2, B2, C2 means 3, 6, 2. Now cos theta equal to A1 A2 means 2 into 3 plus minus 1 into 6 plus 2 into 2 by root of A1 square plus B1 square plus C1 square, root of A2 square plus B2 square plus C2 square. Now cos theta equal to, that is 6 minus 6 plus 4. Okay, after the simplification we are getting, that is simply this is root 9 means 3 and root 49 means 7. Finally we are in the, that is the denominator value is 21. Finally cos theta equal to 4 by 21 and the angle represented in terms of theta. That's why theta equal to, we are taking theta equal to cos inverse of 4 by 21. That is the condition. Now let us practice the problem. Another two planes are given, 3x minus 4y plus 5z equal to 0 and second one 2x minus y minus 2z equal to 5. To find the angle between the two planes, in the same manner, first of all to write the given planes are and to mention the drs to the plane 3 comma minus 4 comma 5. That is one of the point a1 b1 c1. 2 minus 1 minus 2. Okay, this is the second plane of the normals. Now here the angle between the two planes. First of all, to write the formula, angle between any two planes, cos theta equal to sigma a1 a2 by root sigma a1 square into root sigma a2 square. So it stands for sigma a1 a2 means a1 a2 plus b1 b2 plus c1 c2 by root sigma a1 square means a1 square plus b1 square plus c1 square. Root sigma a2 square means that is a2 square plus b2 square plus c2 square, and to find the angle. Okay, in the same manner. Students, listen carefully. This is also one of the important problem. There are two planes. First plane is perpendicular to the second plane. It is very simple concept. It is a very simple concept because here first plane of the normals 1, 2, minus 3. Second plane of the normals here 2, 5, 4. Okay. First of all, to write the given the data, the given planes are, what are the planes? Yes, x plus 2y minus 3z plus 4 equal to 0. That is the first plane. And the second plane is 2x plus 5y plus 4z plus 1 equal to 0. Now, what about the condition perpendicularity the planes? Yes, a1 a2 plus b1 b2 plus c1 c2 equal to 0, and according to the angle between the two planes, and there are two important conditions through the formula, that is a1 a2 plus b1 b2 plus c1 c2 equal to 0. Here first of all, to write the a1 b1 c1 and a2 b2 c2, there are two planes of their normals, and substituting given this expression, a1 a2 means 1 into 2 plus 2 into 5 plus c1 c2 means minus 3 into 4. The a1 a2 b1 b2 c1 c2, so that value is also equivalent to 0. So the given planes are perpendicular to each other. Okay, very simple. Now here the one of the, what is the intercept form? Already that intercept form we have to practice it in the lower session. Okay, intercept x intercept is a, y intercept b, z intercept c. When the intercepts is also just like that treated as suppose on the x-axis, now from the origin of the x-axis of the point, that distance is small a, oa equal to a. So x coordinate is a and the remaining coordinates are 0. So capital A point on the x-axis is a 0 0 and y-axis of the point is capital B. So ABC be the plane. ABC be the plane. Just draw this figure. Okay, shown this figure. This is the one of the figure and intercept on the axis. What is the intercept form on the axis? X, Y, Z axis. We are taking the x-axis of the point is capital A and the y-axis of the point is capital B and z-axis of the point is capital C. So OA distance is small x and OB distance is small b and OC distance is small c. That's why we are treating as capital A point is A00, capital B point on the y-axis. So that is 0 B0, C point is 0 0 C. Okay. Now these 3 points here x intercept A, y intercept B, z intercept C. So that's why that is the intercepts of the plane. here the required equation of the plane is ax plus by plus, here we are taking the gamma z because already that point is given. Here alpha x plus, already a, b, c we are writing as one of the distance on the dimensions through the plane. So that's why write it as the general equation of a plane in terms of alpha, beta, gamma. We are taking this one and so replacing d by del is there. So okay, alpha x plus beta y plus gamma z plus del equal to 0. That is the partial dou. Okay. Now that is the general equation of a plane. Now the general equation of a plane, substituting these 3 points are satisfying in the first equation. So that's why replacing alpha point, here the point is alpha. Okay, capital A point, A0, 0. So OA distance is small a, OB distance is small b, OC distance is small c. Okay, so replacing first point, A point is satisfying in the first equation. We are getting the alpha A because x coordinate is small a. Remaining coordinates are 0. So alpha A plus del equal to 0, alpha equal to minus dou by A. Second one, B point is satisfying in the first equation, beta B plus dou equal to 0 because x and z coordinates are 0. That's why we are given the point is capital beta equal to minus dou by B. And C point is also substituting in the above expression, gamma C plus del equal to 0 because x and y coordinates are 0. We are getting the values gamma C plus dou equal to 0. Gamma value is minus dou by C. So these values substituting in first equation, finally minus dou by Ax, that is the value of alpha, beta, gamma is substituting in the first equation. Finally, we are requiring the condition is dou by A into x, dou by B into y, dou by C into z, and minus is common, minus dou equal to 0. So that's why minus dou is also converting into this side. So that value is positive, taking the positive value, that is dou. Okay, so finally x by a plus y dou is common. So finally we are getting the value x by a plus y by b plus z by c equal to 1. That is the required intercept form of the plane equation. Okay, now how to prove the intercept form? This is one of the important concept, that is 2.3.5. In the lower classes we are nothing to prove, in the previous classes is there. Now directly we have studied the what is the intercept form, x intercept A, y intercept B, z intercept C. Now the intercept form is x by A plus y by B plus z by C equal to 1. That is the directly we have learned and practiced here. But it is especially how to construct the intercept form. Okay, this is one of the proof of intercept form, that is 2.3.5. Now it is very important, according to some other problems are also practiced. Okay. Now here already this is one of the note is there. Here the x intercept A, y intercept B, z intercept C. That's why intercept form of the plane equation. Intercept is entirely different of intersect. Both are confused in the rhyming words, rhyming of the part. Intercept or intersect. Intercept means it is on the dimensional of the expression, and intersect means both lines are crossed checked. Okay, crossed points. Okay. Now, this is if does not intersect x-axis and y-axis, it is parallel to the xy plane. And therefore, the equation of the plane is z equal to c. Okay, that is if a plane does not have at least one of the intercept. Does not have at least one of the intercept. So, one of the possibility on the xy plane means z, we are taking the z equal to c is there. So, that expression is z by c equal to 1. Suppose in the same manner, y by b equal to 1 or y by b plus z by c equal to 1. Okay, that is simple expression on the parallel to x-axis, parallel to y-axis, parallel to z-axis. Parallel to, now if a line of intersection is parallel to x-axis, then its equation of the plane y by b equal to 1 or y by b plus z by c equal to 1 according to the plane is parallel to the z-axis. So that is okay. Now intersection is parallel to the y-axis, then the equation of the plane form is y-axis means x by a equal to 1 or x by a plus z by c equal to 1. Okay. Now both are intersect x-axis and y-axis, but not the z-axis. then the expression of the form x by a plus y by b equal to 1 is there. That is the two-dimensional geometric expression. Okay. Now see this example. The equation of the plane whose intercepts on x, y, z axis. Okay. Now this is your practice purpose. Okay. Now x intercept is 1, y intercept is 2, z intercept is 4, and to write the intercept form is x small x by 1, y by 2, z by 4 equal to 1 is there. And this expression is substituting in the intercept form. Finally, we are getting after the LCM, 4 is LCM. So that's why this is 4x plus, and after the cancelling 4 by, that is the 2. So we are getting that this value is 2y plus z equal to 4. 4x plus 2y plus z equal to 4. That is the form of a plane equation after the replacing of intercepts. Okay. Now, plane equation is given. That plane equation is converting into the intercept form on the coordinate axis. So, d value is 2. How to get the 1? The constant, how to get the 1? Because here the d constant is 2. Now, dividing throughout by 2 is there. Dividing both sides by 2, we are getting the 4x by 2, 3y by 2 minus 2z by 2 plus 1 equal to 0. Okay. After that, here, so 2 by 2 means 1. That is also, now finally we are getting, what is that? Here, x coordinate, x intercept is 4 by 2 means 2. So after the substitution, we are getting x intercept is minus 1 by 2, y intercept is minus 2 by 3, z intercept is, what is that? Minus of minus 1. That value is 1. Z intercept is 1. So finally, here, now just like that, we are converting into the form x by a plus y by b plus z by c equal to 1. So we are getting the intercept values, a value minus 1 by 2, b value minus 2 by 3, and c value is 1. So that is the simple expression on the throughout the dimension x intercept, y intercept, and z intercept. That is this is your practice purpose. Okay. Now, how to form the plane through 3 points? Here there are 3 points is given. These 3 points are non-collinear points. What is the collinear? Students, please tell me. Here collinear already we have discussed in the previous classes. Okay. Collinear means the given points is on the same line. That is called a collinear. Coplanar means the given points is on the same plane. That is called a coplanar. So that's why how to construct the plane equation passing through the 3 points. These 3 points are non-collinear points. First point is x1, y1, z1. Second point is x2, y2, z2. And third point is x3, y3, z3. So this is ax1 plus by1 plus cz1 plus d equal to 0. Say this is the second equation. Now these 3 points are satisfying in the general form. We are getting the remaining 3 equations. So that's why we find the determinant of this part delta equal to. So the enter the values are coefficients of x, y, z, and constant is 1. So these 3 points are taking in this delta expression determinant of this part x1, y1, z1, x2, y2, z2, x3, y3, z3 through the constant of this part. So after the determinant, we are getting the required equation of a plane. That is also one of the simple expression. So we after that find the plane equation through the 3 non-collinear points. So that is the simple expression is there. Okay, delta equal to, say this is a determinant of this part. Okay. After the row operation or column operation, we are getting the simple expression is the plane equation. The plane equation is also in the similar part ax plus by plus cz plus d equal to 0. That is the formation passing through their points. Okay. What is the vector equation of a plane that passes 3 points whose position vectors a, small b, small c? What is the position vector? Already we have seen this one. Here a, b, there are 2 position vectors. One position vector is small r equal to p dot a, and here according to there, these 3 points are given. That is the position vectors is r, small a, small b, small c is given. So how to form the position vector by vector equation? That is the representation of the vector equation is small r equal to 1 minus s minus small t of a. Here, what is the s and t? S and t both are scalars. Okay, scalars, there is no direction. There is no there is no length. Okay, there is no sense. That is the simple. Scalar is nothing but that is the simple field element is there. Okay, all field elements are scalars. Already we have learned what is the difference between the vectors and the scalars. Now, vectors and scalars both are entirely different, because vector is the particular direction. That is one of the directed line segment. Okay, directed line segment is called a vector, but scalar is nothing but it is simple. That is the field element or any numerical part. Okay. Now here the position of a vector equation of a plane passing through the points, that is the representation of a vector passing through the points here a, b, c. So that is small r equal to 1 minus s minus t of a plus sb plus tc. That is the vector equation of a plane passing. There are three points whose position vectors are small a, small b, small c. So proof is not necessary here. Okay, proof is not necessary. Okay, suppose 4 points is given, it is also say in the same manner. 4 points is given, replacing xyz by that is x4 y4 z4. That is after the simplification of the determinant, we are getting the values delta 1 equal to mod x1 y1 z1 1, x2 y2 z2 1, and x3 y3 z3 1. Through the matrix of the determinant of the part, after the determinant of this part, we are getting the plane equation. Just like that, form of a plane is there. Okay, that is the simple expression. Okay, there is no doubt. How to find the one particular point is given. Say that is capital P of x1, y1, z1. How to find the length of the perpendicular from a point to a plane? Already we know that here point is capital P of x1, y1, z1. Now it is from the plane, perpendicular distance, the perpendicular distance of the point to the plane, Lx plus My plus Nz equal to P. So that is plus or minus Lx1 plus My1 plus Nz1 minus P. That is through the normal form. Now in the ordinary here the Ax plus By plus Cz plus D equal to 0. Okay. How to get the perpendicular distance? Now given the point is on the plane, that is modulus of, okay, modulus plus or minus, modulus means plus or minus of Ax1 plus By1 plus Cz1 plus D by root of A square plus B square plus C square. After the normal to the plane means Lx plus My plus Nz equal to P, that is plus or minus Lx1 plus My1 plus Nz1 minus P. Okay, after removing of this concept, we are getting the value is that is the simple expression. This is the that is the general form of the plane equation. What is the perpendicular distance from the particular point? Here particular point is capital P of x1, y1, z1. This point is lie on the surface. Surface means it is nothing but to the plane. Okay, so that plane is Ax plus By plus Cz plus D equal to 0. That is plus or minus mod means Ax1 plus By1 plus Cz1 plus D by root of A square plus B square plus C square. This is the particular distance from the point. Okay, this is the L value, M value, and N value is there. P value is plus or minus D by root of sigma A square. Now after the vector representation is R minus A dot alpha A cross beta bar equal to 0. That is the vector representation of the perpendicular to this perpendicular distance from the point to the plane is there. Here R minus A and alpha A bar and beta. Now these three are coplanar. That is the triple product. These three are, because here A is involving with the position vector. Here A means these three are triple product is 0. Scalar triple product is 0. So that is not necessary here. So you see this problem. This problem is very important. One point is given and required play of given the plane is 3x minus 6y plus 2z plus 11 equal to 0. Find the perpendicular distance or length of the perpendicular the point. Okay. Now, already we know that formula ax1 by1 cz1 plus d by root of a square b square c square. So, ax1 means 3 into 2. Point is also substituting, replacing x1 y1 z1. So, 3 into 2 minus 6 into 3 plus 2 into 4 plus 11 by root of a square means 3 square plus minus 6 whole square plus 2 square equal to, after the simplification we are getting the value is 1. So, one particular point is given and plane is given, and to find the length of the perpendicular through the origin means that is a, b, c are 0. So, we are getting the mod d by root of a square plus b square plus c square. But here, one particular point is given. So, that's why perpendicular distance from the point to the plane is mod ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square. That is, this is also your practice purpose. 114, that point is given. Now, see this one. Here the replacing of x1, y1, z1 after the substitution of giving this expression mod ax1 means 3x1. 3 into 1 minus 6 into 1 plus 2 into 4 plus 11 by root of a square means 3 square plus minus 6 whole square plus 2 square. After the simplification, we are getting the length of the perpendicular distance. Okay, length of the perpendicular or perpendicular distance, whatever it is. Here, see this one, distance between any two parallel planes. Very simple concept. Okay, there are two planes is given. Those planes are parallel planes. Parallel planes means same point, same coordinates. Ax plus distance is entirely different. Okay, here xyz be the point on the first plane, and same second plane is also xyz be the one of the point on the second plane. So, same point in between any two planes, so that those planes are called parallel planes. Okay. Now, here ax plus by plus cz plus d1 equal to 0, ax plus by plus cz plus d2 equal to 0. How to define the distance between those planes? So, that is simple expression plus or minus here distance between the parallel lines equal to distance, perpendicular distance from point to the plane. This perpendicular distance from point means small p to the plane means first equation. Okay, and the second equation. So, there are same point is there. So, that is x1, y1, z1 is substituting in the both planes. We are getting the distance are different. That's why d1 minus d2 by plus mod d1 minus d2. So, after the removing of the modulus, so we are simple plus or minus d1 minus d2 by root of a square plus b square plus c square. So, this is the distance between the parallel planes. Modulus plus or modulus d1 minus d2 over r plus or minus d1 minus d2 by root of a square plus b square plus c square. See the problem, there are two planes are given here. Now, here a1, b1, c1, here a2, b2, c2 is there. Point is on the same, xyz is the same. So, distance means plus or minus, d1 means minus 7, d2 means 6. d2 means 6 is there. So, mod d1 means minus 7 minus d2 means 6 by root of a square means because a, b, c. Now, both planes are, drs are the same. 12 minus 3, 4 and this is the 12 minus 3, 4. So, that's why the distance is different. Okay. Now, after the substitution of the given this power expression plus or minus d1 minus d2 minus d2 means 6 by root of a square, b square, c square. After the simplification, we are getting the value is 1. Now, this is also your practice purpose. There are two planes is given. 2x minus y plus 3z equal to 6 and second one minus 6x plus 3y minus 9z equal to 5. Now, here a1 is 2 minus 1 3. Now, this is also same because this is 3 is common in the second plane. After the common, minus 3 is common. So, 2x minus y minus, what is that? Minus 3 is common. So, 2x minus y plus 3z equal to, what is that? 5. So here the minus 3 is converting into this side minus pi by 3. So that's why d2 equal to minus pi by 3. So again d2 value converting into this side, that is also plus 5 by 3. So d2 equal to 5 by 3 and d1 equal to minus 6. So mod d1 means minus 6, minus 6 and minus 5 by 3 by root of a square means 2 square plus minus 1 whole square plus 3 square. We are getting the result, that is the distance between the two parallel planes. What is the system of planes? That is the intersection of this part. Okay, now enter, this is the remembering points. Once again you have to repeat this one. What is the intersection of the planes? That is the normal plane equation. And first equation, it represents here lambda be any one of the scalar. Now it is comparing it with, because here what is the parallel plane equation given, that is the normal form, ax plus by plus cz plus d equal to 0. This equation represents the same system. That is the there is a parallel plane equation is ax plus by plus cz plus lambda equal to 0. This is the parallel to the given the normal form of the plane equation, either lambda or k, whatever it is. What is the normal form of the plane? What is the parallel plane equation? Ax plus by plus cz plus lambda equal to 0, or replacing lambda by k, whatever it is, there is no problem. Okay. Now we are taking this equation represents the system of planes perpendicular to the given line. With the drs are also same. A, B, C are the drs, lambda being the parameter. Okay. Now in the same, that is the equation a of x minus x1, b of y minus y1, c of z minus z1 equal to 0. Okay. Now here the lambda equal to, what is the lambda value? Okay. Now this is x minus x1 because a value is 1, b value is lambda, c value is mu. So finally we are getting the lambda value is b by a, mu value is c by a. It represents the system of plane passing through the point. What is the point? x1, y1, z1. So lambda and mu both are being parameters, and according to this one, lambda value is b by a. Comparing it, both the equations are parallel. So that's why we are getting the value is b by a and mu value is c by a is there. There are different planes are there. Lambda s1 plus mu s2 equal to 0. Both are representing the system of planes through the line of intersection of the planes. First plane is ax plus by plus cz plus d equal to 0. Second plane is a1x, b1y, c1z plus d1 equal to 0. Here lambda and mu both are being parameters, but not both are 0. Okay. Now it represents the first degree equation in terms of x, y, z. So that's why, what is the corollary? The intersection of the planes. There are two planes are given. Suppose P1, first plane is P1, here S1 equal to 0, second plane is P2, now it represents the S2 equal to 0. What is the intersection of the plane? S1 plus lambda S2 equal to 0. That is a simple expression. Okay, find the, so just you have to see this one. S1 plus lambda S2 equal to 0. This is the intersection of the plane equation. Then the condition of intersection of any two planes, S1 plus intersection, it is nothing, just you have to play, you must understood here. Okay. Now intercept or intersect, both words are confused here. Intercept means through the image of the dimension. Okay. Now here the intersection means both are connected, both are joined here. That is the crossed part is there. Both lines are crossed. That is the intersect of the point. Same point is there. Okay. Now here, see this one, find the equation of the plane passing through the points. First point, second point, third point. There are 3 points is given. How to find the plane equation? Okay. According to the point, what is the form of the equation? A of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. First of all, you have to write the expression given that, and these 3 points are substituting, these first 2 points are substituting in the general expression a of x minus x1, b of y minus y1 plus c of z minus z1 equal to 0. So that's why this is the first point is also substituting, and the equation, first equation passes through q and r, and according to this equation passing through the remaining 2 points. So replacing the q point and r point, replacing of xyz by q point and one time, and the next time is the r point is also substituting in the first equation. So we are getting the values of q point is 342 is there, and r point is 706 is there. These 2 points substituting in the first equation through the given the point is first point is capital P. So we are getting the values a plus 2b plus 3c equal to 0, and first equation passing through the q point, and same first equation passing through the capital R point. Means replacing of R point is replacing xyz by given the point is capital R. Okay, we are getting the 5a minus 2b plus 7c equal to 0. Now, by the cross multiplication rule, do you know that cross multiplication? Now, either simplification, whatever it is, a, b, c is the common. Okay, now they here nothing but here. Okay, a, b, c, we are taking the values first of all by the cross multiplication rule means we are taking the values of b from the beginning of b and c coefficients. Okay, 2, 3, 1, 2. 2, 3, 1, 2 is there, and second one minus 2, 7, 5, minus 2. When the cross multiplication rule is 2, 3, 1, 2 is there, minus 2, 7, 5, minus 2 is there. After the simplification, we are getting the A of, okay, 14 plus 6 plus B of 15 minus 7 plus equal to C of minus 2 minus 10. So after the simplification, A by 20, B by 8, C by minus 12. After the cancellation by 4, 5 is 4, this is also common. Okay, 28 minus 12. Okay, fourth table is common. So dividing by 4, so 5 times, and this is the 2 times, and this is 3 times. So we are getting the value A, B, C values are 5, 2, minus 3. Okay. Now these values are substituting in the first equation. We are getting the required plane equation. So that is 5x plus 2y minus 3z. After the simplification of the constant values, we are getting the value is minus 17. So this is the required equation of a plane passing through 3 points. Okay, when the 3 points is given, how to form a plane equation? This is simple part. Okay, there are 2 type of models here, but here only one model is given here, and the remaining 2 models are also very simple. Okay, through the determinant of this part. Okay, okay, students. This problem is also very, very important in the final examination. That is 2.6.2. Okay. Now already time is over. Tomorrow we will meet again, and continuing of the class from the 2 towards 2.6.2. Now this problem is very important in the final examination. Okay, there is no, if you have any doubt, please contact us and personally through WhatsApp. Please note down my mobile number 9989476833. This is my mobile number, and you must contact us and personally for the subject point of view. Okay, thank you one and all. Wish you all the best and wish you good luck. Okay, if you have any doubt, students, any doubt here? Okay, no problem. If you have any doubt, please contact us and personally through WhatsApp. Okay, thank you one and all. Wish you all the best. Please stay on the line. Okay, thank you. Tomorrow we will meet again, same session. Okay.